We now know how our world ends. Our affinity with sci-fi movies and perhaps the Bible would point toward the big, bad apocalypse. But what if we tell you that the end of the universe is no different than its inception? The James Webb telescope has revealed that the universe has stopped expanding. Popular scientist Brian Cox made this prediction years ago. In doing so, he gave us the most realistic starting point to imagine the end of the world.
We can look to light that began its journey before there were galaxies. And that's the oldest light in the universe, which is, by the way, one of the pieces of evidence when people say, I don't believe in the Big Bang. The answer is, well, you can see it.
We're heading towards Big Bang 2.0. Join us as we explore why the world has stopped expanding and James Webb's terrifying discovery. The Big Bang Theory. If we're certain about anything in our knowledge of the universe and its history, it's the fact that our very epoch of existence is centralized around this event called the Big Bang. Of course, there are alternative theories that recognize the beginning of the universe, such as eternal inflation or an oscillating universe. But we're not getting into the validity of these theories today, mainly because the astronomical community has now readily accepted that our history in this universe starts with the Big Bang. And the ideas that succeed the Big Bang are also based on the same common point of the universe's birth. While the Big Bang is a common word in the theoretical knowledge of astronomy and space, we're hardly aware of the no's and the how's of the phenomenon. Unless you're a nerd who has spent hours watching some excellent visualization of the Big Bang. To be fair, the phenomenon was more than an explosion, or so to speak. Simply put, the Big Bang finds its origin in a single point, a point that was infinitely hot and dense that inflated to extreme lengths. All of this was when the universe was incredibly young. Believe it or not, at the time of the Big Bang, the universe was only 10 to the power of minus 34 seconds old. That is, 100th of a billionth of a trillionth of a second in age. This is when the universe experienced an incredible burst of expansion, aka the infamous explosion or the inflation. During this process, the space expanded faster than the speed of light. So yeah, you wouldn't have even blinked when the universe grew 90 times in size, almost instantaneously from subatomic-sized to golf ball-sized. 1 second after the inflation, the universe began to cool. And that led to the formation of matter as we know it today. So yeah, as far as the timeline goes, within a second, our universe was full of every particle we've learned about in our chemistry class, willingly or otherwise. Protons, neutrons, electrons, anti-electrons, photons, and neutrinos are the legacy of the Big Bang. Magical, right? Well, figuratively, it looks like it. But our understanding of the universe's inception is highly theoretical. We've come a long, long way since the first moon landing, and since then, our technological advancement has grown exponentially. Back when scientists were studying the Big Bang only based on mathematical formulas and scientific models, they wouldn't have imagined that we'd be exploring the possibility of life on Mars. The origin of dark energy. Back in the 1990s, NASA and its credible scientists had some very conclusive ideas about the expansion of the universe. The most fundamental unit of their scientific understanding was gravity. While that much still remains true today, we've some entirely different ideas about the speeds at which our universe expands. As we've already discussed earlier, scientists had a theoretical prediction about the universe's recollapse that would cease the expansion as we know it today. But also, the contesting idea was equally terrifying, if not jarring enough. Too little energy density would mean that our universe would never stop expanding. The uncharted bizarreness of the idea is quite limited today. But you see, it was the 1990s. And scientists had little technological help to find tangible or observational data for their predictions. What they were certain about was that as our universe ages, gravity would definitely decrease the rate of expansion all over the course of time, of course, and even intuitively, it makes sense. Gravitational pull brings galaxies together. This is something we've already established. So, as the universe would expand, the gravitational force would resist widening the distance between the heavenly objects. Since our universe is just a patch of matter, of course, the attractive gravitational pull would keep the matter intact. This theory was also extended to understand the rate of the universe's expansion. Scientists believed that since gravity is the binding glue for all of the matter and has existed since the universe's inception, the rate of expansion had to slow down. Sure, we didn't have any means to observe this phenomenon or carry out some big data testing, but theoretically this made complete sense, until it didn't. In 1998, the invention of the Hubble Space Telescope, or HST, changed everything we knew about the universe. HST was effectively used to study the distant supernova in our universe that explain the fluidity of our space. This is to say, scientists employed supernovas to study the expansion of the universe. What they found out was completely opposite to what they knew about our universe. And let's just say, scientists were left completely dumbfounded and clueless. After all, the whiplash was monumental. Not to mention, this single discovery meant that astronomical studies had to be inherently rewritten and revised. Scientists had to look back at their theoretical studies and change everything on the basis of what the Hubble Space Telescope showed them, and there was no room for error of judgment. For the first time in the study of the universe, seeing was believing. It had turned out that gravity wasn't slowing the expansion of the universe at all. In fact, the universe was expanding at a higher acceleration than it had ever before. You heard that right. Ever since the universe's inception, the rate of expansion had only increased from its earlier data points. For the most part, this unexpected theory was hard to explain. Of course, gravity couldn't cause the faster acceleration. If anything, gravity should have fought valiantly to de-accelerate the rate of the universe's expansion. But by all accounts, gravity was rendered powerless. In fact, to this day, we don't know how or why the universe was expanding to astronomical degrees. As per theoretical knowledge, the expansion should have slowed down unless and until there was an anti-gravitational force in the universe that was effectively overpowering gravity. And until the recent discovery of the James Webb Space Telescope, scientists were mostly of the opinion that our universe is a huge battlefield. Here's why. You see, after Hubble's discovery, the scientific world was in a crisis. Agencies like NASA wanted quick explanations for the unprecedented cosmic acceleration. The end of Big Freeze. While we figure out the logistical and feasible mechanism to study the contraction of the universe, certain predictions are based on our prior theoretical knowledge. What we definitely know is that our universe is never at a standstill. It either expands or contracts. In the case of the latter, gravity ends up dominating the universe. We can't be certain what happens to dark matter, yet its powerlessness can finally put one popular theory to rest. If the universe never starts to expand again, the end of all life would be more catastrophic than the Big Freeze. Humans have long theorized that the universe will freeze to its death. But that was only a possibility when dark energy was expanding our universe at accelerated rates. Galaxies and stars were moving away from us. In other words, the universe was disappearing. Scientists expected that in some trillion years or so, the formation of stars will stop entirely as black holes latch onto any remnants of the universe. In this dark era, it was predicted that all energy in the universe will be evenly distributed. And of course, when we use the word energy, we're also talking about heat. So, the final temperature of the universe would be close to zero, and everything would be just eternal darkness. Now, the Big Freeze isn't a possibility, but let's just say we've dodged a bullet to stand in line for the next one. The Big Crunch is terrifying, yet it's our distant reality. Found this video informative? Give us a like and subscribe to our channel.